On May 13th, 2019, astronomers watched in horror as something impossible happened at the center of our galaxy. Sagittarius A star, the supermassive black hole that's been quietly sitting at the heart of the Milky Way for billions of years, suddenly became 75 times brighter than ever recorded. For 2 hours, it raged with an intensity that defied every prediction. And then, just as suddenly, it went silent again. Scientists scrambled. Telescopes around the world turned toward the galactic center. Data poured in from space observatories. And what they found changed everything we thought we knew about the monster living 26,000 light-years from Earth. Because Sagittarius A star didn't just flare, it screamed. And the question that's been haunting researchers ever since is simple. What woke it up? This is the story of the sleeping giant at the center of our galaxy. A black hole with the mass of 4 million suns. An object so massive it controls the orbits of thousands of stars whipping around it at 5,000 kilometers per second. But here's what terrifies scientists. For most of recorded history, this monster has been eerily quiet, almost dormant. Like a sleeping dragon surrounded by food it refuses to eat. Until May 13th, 2019. That flare wasn't just unusual, it was a warning. Evidence of something lurking in the darkness, something that could reshape the entire galaxy if it fully wakes up. And based on what we're learning, it might already be stirring. Let's go back to the beginning. For most of human history, we didn't even know there was a center to our galaxy. When you look up at the Milky Way, you see a band of light stretching across the sky. Beautiful, mysterious, impossible to see through. That's because between us and the galactic center lies an impossible wall. Clouds of dust so thick they block visible light completely, like trying to see through smoke. It wasn't until 1974 that astronomers detected something strange, a powerful radio signal coming from the constellation Sagittarius. They called it Sagittarius A star. The asterisk wasn't random. In physics, an asterisk means excited state, something with more energy than normal. They had no idea how right they were. For decades, Sagittarius A star was just a radio signal, a mystery hiding behind curtains of cosmic dust. But in the 1990s, 2 teams of astronomers, one led by Andrea Ghez at UCLA and another by Reinhard Genzel in Germany, made a breakthrough. Using infrared telescopes that could pierce through the dust, they started tracking individual stars near the galactic center. And what they saw was impossible. Stars moving at speeds that should not exist. One star, called S2, completes a full orbit around an invisible point in just 16 years. At its closest approach, it's traveling at 3% the speed of light. 3% the speed of light. Think about that. When they calculated the mass of whatever was pulling these stars around, the answer was staggering. Over 4 million times the mass of our sun, packed into a space smaller than our solar system. There was only one explanation: a supermassive black hole. But here's where it gets weird. This black hole should be one of the brightest objects in the sky. Most supermassive black holes, especially ones this massive, are actively feeding. They're surrounded by blazing disks of matter spiraling inward, heating to millions of degrees, shooting out jets of radiation that can be seen across the universe. Sagittarius A star does none of that. It's quiet, almost invisible, like a lion surrounded by prey, just lying there, barely moving. Scientists call it radiatively inefficient, which is a fancy way of saying we have no idea why it's not eating. The material is there. Gas clouds drift past, stars shed their outer layers nearby, dust swirls in the gravitational field. All of it should be feeding the black hole. Instead, most of it just escapes, blown away by turbulent magnetic fields, heated to the point where it can't fall in. lost to space. Sagittarius A star is starving itself, or something is preventing it from feeding. And that brings us back to May 13th, 2019, because on that night, for just 2 hours, the sleeping giant fed. The 2019 flare wasn't the first time Sagittarius A star brightened. The black hole has occasional bursts, brief flickers in X-rays or infrared light that last a few minutes before fading. But this was different. 75 times brighter than normal, sustained for 2 hours. Astronomers watching in real time couldn't believe what they were seeing. Some thought their instruments had malfunctioned. They hadn't. What caused it? Scientists have 3 theories, and all of them are terrifying in different ways. Theory 1. A gas cloud called G2 finally got close enough to be torn apart. G2 had been drifting towards Sagittarius A star for years. When it passed near the black hole in 2014, everyone expected a massive flare. Nothing happened. The cloud survived, stretched and distorted, but intact. What if pieces of it didn't escape? What if, in 2019, leftover material finally spiraled in, superheated, and released a burst of energy before vanishing into the event horizon? If that's true, it means even small amounts of matter falling in can cause massive flares. And there are thousands of gas clouds drifting near the galactic center. Theory 2. Magnetic reconnection. The space around Sagittarius A star is threaded with magnetic fields, invisible lines of force twisted by the swirling plasma. Sometimes these fields snap and reconnect, releasing enormous amounts of stored energy in an instant. Think of it like a rubber band stretched to its limit, then suddenly snapping back. Except this rubber band is made of magnetism and contains the energy of 1 billion atomic bombs. If that's what happened, it means the black hole's magnetic environment is far more violent than we thought, and those fields could snap again at any time, without warning. Theory 3. Something fell in. A star, an asteroid, maybe even a smaller black hole. If a dense object got too close and crossed the point of no return, the tidal forces would rip it apart in a process called spaghettification. The material would spiral inward, heating to millions of degrees, producing exactly the kind of flare we saw. The problem? We didn't see anything fall in, which means either our instruments missed it, or the object was too small and dark to detect. A black hole eating something we can't even see, feeding in secret. Each theory points to the same conclusion. Sagittarius A star is not as dormant as we thought. And here's the part that should keep you up at night. Scientists studying X-ray echoes, radiation bouncing off nearby gas clouds, have found evidence that just a few hundred years ago, Sagittarius A star was hundreds of thousands of times brighter than it is today. Let that sink in. In the cosmic blink of an eye, geologically speaking, this black hole was a roaring monster, a quasar-like beacon lighting up the galactic center. And then it went quiet, like flipping a switch, which means the sleeping state we see now might just be a pause, a brief intermission in a much longer, much more violent story. What if the 2019 flare wasn't a one-time event? What if it was the black hole stretching, yawning, beginning to wake up? Because if Sagittarius A star fully reactivates, the consequences wouldn't just be visible, they'd be felt. Let's talk about what happens if Sagittarius A star wakes up. Right now, the black hole is barely feeding. A trickle of matter falls in occasionally, producing weak flares and faint radio signals. But if a massive gas cloud, or a disrupted star, or a collision with another black hole delivered a steady supply of fuel, everything changes. Sagittarius A star would become an active galactic nucleus. The accretion disk around it would heat to tens of millions of degrees, glowing so bright it would outshine every star in the Milky Way combined. From Earth, 26,000 light-years away, we'd see the galactic center transform, What looks like a faint haze now would become a blazing point of light, visible even during the day. But that's just the beginning. Active black holes don't just glow, they blow. Powerful winds and jets of high-energy particles would erupt from the poles, driven by twisted magnetic fields. These outflows could sweep across the galaxy, pushing gas away from the center, halting star formation in the inner regions. Earth itself is far enough away that we wouldn't be in immediate danger. The radiation would take 26,000 years to reach us, and by then it would be weakened by distance. But the galaxy would change. The structure we call home reshaped by the awakening of its central engine. And here's the thing. This has happened before. The Fermi bubbles, two enormous lobes of gamma-ray emission stretching 25,000 light-years above and below the galactic plane, are evidence of a past outburst, something violent enough to blast material outward at incredible speeds, creating structures visible across half the galaxy. That outburst might have happened just a few million years ago. Geologically recent, close enough that early humans might have been alive when it occurred, completely unaware that the sky above them had just recorded an explosion of unimaginable power. And it could happen again. In fact, it will happen again. The question isn't if, it's when. Because in about 4 billion years, something unavoidable is coming. The Andromeda Galaxy is on a collision course with the Milky Way. When the two galaxies merge, their central black holes, Sagittarius A star and Andromeda's M31 star, will spiral toward each other. For tens of millions of years, they'll orbit closer and closer, sending out gravitational waves, distorting space itself. And when they finally merge, they'll merge into a single supermassive black hole, possibly 100 million times the mass of the Sun. During that process, the galaxy center will blaze with the intensity of a quasar, fueled by the chaos of two galaxies tearing each other apart. Star formation will explode, gas will flood inward, and the black hole will feast. But we don't have to wait 4 billion years for Sagittarius A star to wake up. It could happen in 1,000 years, or 100, or tomorrow. Because right now, astronomers are tracking clouds of gas drifting near the black hole. Some of them are on trajectories that will bring them dangerously close. If one of those clouds gets captured, we could see another flare, bigger than 2019, longer, brighter. And if the conditions are just right, if enough material falls in at once, the sleeping giant could open its eyes and stay awake. The black hole at the center of our galaxy isn't just a curiosity. It's not just a strange object hiding in the darkness. It's a force, a shaper of galaxies, a regulator of star formation, a cosmic engine that, when it runs, can change everything around it. For now, it sleeps, but the 2019 flare was a reminder. Sagittarius A star is still there, still waiting, still capable of violence we can barely imagine. And one day, possibly soon, it will feed again. When that day comes, we'll have a front row seat to one of the most spectacular and terrifying events in the universe: the awakening of the monster at the center of our galaxy.